Well, hi, and welcome to my shop for another day on this radio. I don't think this will be a very long video. So really I've kind of replaced, I think every capacitor in it except for a few down here, 1, 2, 3, that were installed about 20 years ago or so. And then this original one, which I'm quite certain this is an original, I'll take that back, I think this is a replacement. And this one, which I'm quite sure is the original one. But this is a very interesting one here that's right across the power line. So I've looked these over and I've done a lot of testing of the various capacitors that I've removed from this radio previously. So many of these have turned out to be actually in very good shape. These three appear to me to be in good shape. I'm just looking at them, but I know the type they are, the age they are, the results of previous tests. I think the wisest thing I can do is just leave these guys there. There's a little bit of work left in here then from whatever happened in the late 1998, I think it was. I'm not sure when. So we'll leave a little bit of that in here where I'm pretty sure it's working fine anyway. That leaves just this capacitor and this capacitor, and that's what I'm focusing on in this video. So we're going to start right off the bat with this one. And what's strange about this one, it's just an odd looking capacitor. How it is that somebody managed to change, you can kind of see them over here on my bench. So many capacitors and none of them are the same type. Basically you got a selection of every capacitor manufacturer's product here from the I don't know what, this would be the 1980s probably. Go there. We're going to go here. Now, some of the capacitors I took out of here, especially the one I dug out from way down there, I didn't test it. So we're going to test those too as soon as I can find the one I just cut out there, which is making a run for it down here somewhere. Here he is. There he is. TCC metal mite, in quotes, metal mite. So this, well, that, you know, now that I've got it out, it looks like it's got rubber ends on it. One is red, one is black. Boy, this really looks like a electrolytic capacitor, but I'm sure it's not. You know, it has a temperature on it, 71 degrees C, written on it there. You probably can't see that. 0.01, 500 volt, metal mite. So I'm thinking the 71 degrees C is one of two things. It's either don't get this any hotter than 71. 71 is pretty darn hot. Or the other one is at 71 degrees this thing meets its stated standard. So at 71 degrees it's a 0.01. I'm not sure. And they put a metal can on it wrapped in plastic. Course, shrink plastic here, but with rubber ends. Okay, enough looking at it. Let's see if it works. Let's check it out. So, metal can's a good thing. Metal blocks moisture. Nothing else does. Even glass does not block moisture 100%. Okay, there we go. Now we're going to start with a 50 volt test. You can kind of see the open eye here. There we go. Good, 150. Oh, won't open at 150. So in fact, it's not great. Okay, so I'll stick a brand new, spanking brand new 0.01 in there, and then we're on to the next one, a much more interesting capacitor. Let's take a look at where this capacitor is. Now it's soldered on a terminal here across to another terminal. Could be a spare terminal. I'm just looking. No, it's not. So it's going from one tube terminal to a terminal strip, a single terminal strip. That's a terminal strip with no strip. There's no strip to it. But in fact, On the schematic, it's sitting here. This is kind of interesting. We have a capacitor here. We have an audio choke coil here in series. And then we have the tone control. This is on the front of the radio. And this is the variable part that's going to slide up and down here. Selecting, so what exactly is going on here? So if you select more and more of this resistor, you push more and more of the signal through here, or you end up with a greater portion of the signal being that which went through here. When it's a choke in series with a capacitor and the control here, you know, so in the end, this is what I imagine this is doing. That as you move this control up and down, you are simultaneously boosting up the treble while knocking down the tone, the bass, or boosting up the bass while knocking down the treble. Now most tone controls, all they do is shave off the treble. And they never boost the bass. I should say never, but the simplest ones in the simple radios, that's all they are. They're just a treble cut tone control. Bass is always the same. But this one seems to be like a seesaw here a little bit. I don't know. I've never seen that before. Couldn't really analyze that 100%. So that's the capacitor though. C49 in the tone control. I seem to remember the tone control not controlling much. C49, yeah, 0.01, same thing that's in there. You know what I didn't do? I never tested the value. It was a little leaky. Let's not worry about it. We're going to put in the 0.01 into this position. Okay, so that guy's in there now. Now the next one is this one. He's disguised. You might not even recognize that as a capacitor. So this is kind of an interesting guy. Look at how symmetrical it's been installed. It's on its own terminal strip. That's going to make things easy for me. And where is it connected? So this is the on-off switch, which I've shorted out by just wrapping wire around it, which I cannot forget about. So you can see one wire from one side of the capacitor goes straight over to here. The other side is following this wire to the other side of the switch. Huh? Huh? That doesn't quite make sense. That's certainly not how it's shown on the schematic. That didn't make sense, what I just did. So I'm probably getting mixed up on some wires here. Let's just see. So one side of the capacitor. This capacitor has 3 leads on it. It has one on this end, one on the other end, and the body itself is the third common lead, if you like. It's actually 2 capacitors in one. So this is from the capacitor to the switch. Should be 0, of course. Now this side, if this shows up as a 0, I'm going to have to stop and... Oh, maybe I misinterpreted where that wire's going. No, I did it right. Yeah, there's a wire coming back here to this plug on the back, which would be for the amplifier. Didn't really notice that before. There's another wire, a new wire installed here. It's kind of wrapped around. It looks like somebody tried to make this on all the time, as opposed to being switched on and off. I'm not exactly sure what this other wire is doing here. Let's stay focused, Jim. Try to stay focused if you can. So now we're going to look at the other side of the capacitor, the same terminal here. Oh my gosh, what has happened? So for what I'm measuring, now let's just measure right across the capacitor. Something's been done here. Short circuit, not through the capacitor. This is a short circuit around it. But basically this wire and this other wire that are coming out of here. Oh, wait a minute, I'm really reading this wrong, aren't I? I'm really reading this wrong. Hey, a massive confusion on one of the simplest things on the radio. Okay, let's just walk away from the confusion. Here, this will unconfuse me for sure. So here's the plug that goes in the wall. And this, I'm guessing, is the on-off switch. Right there. Carry on. Here's the connections to the big transformer. We carry on a little further and we encounter this capacitor. This is the one we've been fiddling with. This represents the CAN part, goes to ground, which it does, and then these are the individual capacitors. These are small, 0.006 microfarads. C53, okay, let's see 53. C53, right there, 006, 006, 600 volt capacitor. Doesn't say anything more about it. So basically, we should be able to find right off the plug, beyond the switch, wires going straight to the transformer, and then those two same wires should be going to this capacitor. This capacitor's across. Oh right, this isn't even in here. This is in the amplifier, separate power amp unit. Right. It doesn't really matter. This capacitor is doing a favor to both these things. And what is it doing? It's supposed to, I think, shut down any radio signals that are coming in from the power line, and short them out and get rid of them. And they're pretty much shorted out by these. I'll take that back. If you put RF across one of these power transformers, I think the power transformer looked pretty much like an open circuit to the RF, so you got to kill it here. Can't kill it in this coil, so I'm going to kill it here. So if this guy's not working well, not doing his job, then some external interference of various sorts would be presented into the radio a little bit, and that's not good. And in today's world, there's a ton of stuff out here. We're in plug land. Oh my god, all kinds of noise sources. My shop is full of them. Mostly computer equipment, of course. Okay, so it should be easy to figure this out. Let's go take a look at the radio again. Should be easy to figure this out. So where's the power? Where's the power? Let's follow the power coming right into it. So here it comes in here. Clamped very firmly down here. Nicely done. Nicely done, whoever put this cord in. So the green wire, the one I'm most concerned about, is it bolted to the chassis back here. The white wire is brought over to the terminal strip. And a black wire, so this is the one that's been reconnected here, or replaced, or something. Something's been done. Wrapped it around here, and it comes to the one side of the switch. So the other side of the power is coming to this terminal. And then the other side is coming here and then coming back to this terminal. So that's how the two sides get here. But I've shorted out the switch here. Now, so it's as if the switch is closed. So then from here we've got one wire going into the big transformer. That'll be the primary wire. The other primary wire tied down here. So this wire is getting its power from the white wire, basically way back here. Funny how there's such simple things. Yeah, so if you look at the transformer and think about it this way, here's the two transformer primary leads. One goes to one side of the outlet and the other one goes to the other side, of course, through the switch. Okay, so that's all just normal. Why this wire is here? Why is this wire here? I'm gonna have to assume So by delivering this new black wire to this side of the switch, yeah, I think it means it's permanent power. No, that can't be right. You don't want permanent power here. There's no on-off switch on the amp. Okay, I'm just killing myself for no good reason here. Right, let's just get on with dealing with this capacitor. So I'm going to nip it off the terminals here. And then I think the metal bracket is soldered on right there. So we're going to attempt to desolder that. Now this is going to get plenty. There's a pretty significant heat sink going on in here. Goes. Come on, man. Should just suddenly drop right off. There we go. Okay. Don't grab it. Ooh. Some bad smoky smell there. There it is. You can see it says 0.006, 006, 600 volt. This can't be that hot now, can it? No. So they've brought a lead out. Get a little better focus on it. They brought a lead out. Just run it down the outside of the can and attach it here. So it's not so much that the can itself is a terminal. Is a plate, is actually integral to the capacitor. Hey, let's test this right away. Okay, 50 volts. Open right up. Not opening all the way on 150. The other side, 50 volts, probably exactly the same. Open right up, 150, exactly the same. So I won't bother trying to measure the value of this. This is a very small capacitor to have across the power line. 0.006. So I need to get two. Well, I need to dig up a couple of specialized capacitors for this. Hunting I will go. Okay, so I've got the two replacement capacitors in there, and just to show you, it's one like this, which is a little bit of a different type of capacitor. This one is marked with an X2 on it. X means cross the line, or for use in line. I think what makes these special is if they short out, they don't catch fire or explode or something like that. I think that's what makes them special, because they're going right across the power line. You might as well be shoving these right into an outlet. In fact, you know, if it's going to short out, you can just imagine how big a bang you can get. Yeah, regular capacitor might be set on fire. I think that's the concern. Don't quote me on it. Nobody ever quote me on anything. And I'll just give you a close look at that too. So we've gone from one integral capacitor to two separate ones here. just installed on the terminal strip, just like the last one. So there we go, 2 rugged capacitors in. And talking about capacitors, why don't we test one I forgot about earlier? How could I forget to do this? So let's do it now. This is the one I dug out of the radio. I dug out from way down here, and then I don't think I tested it after doing that. So let's do it now. It's this one here. There's a few other capacitors I've taken out and not tested, I think, from just basically oversight. Okay, here we go. Okay, I think you can see the eye there. Down here. 50 volts. Opened right up. 150. Oh my gosh, it's opening right up. Okay, so what's the rating on this guy? Probably 600 volts. So we can go another step higher. Look at that, son of a gun. Okay, that was an awful lot of work to replace the capacitor. It appears to be, you know, it looks bad, but appears to be good functionally. So let's since it's not, appears to not be leaking, let's check its value here. This is a pretty small one, I think. If I remember right, 0.006. 0.006 is going to be on this scale. 0.006 is right in this area here. Oh, doesn't open fully. You can't see it on camera, but I can see that there's a little something happening here, but not enough to open it. So I'm going to repeat the voltage test, the leakage test. I'm going to watch now how quickly this operates. How quickly it charges the capacitor. That's really what I'm after. Yeah, looks perfectly normal. Well, I think I can only say this is actually a good capacitor. Just could not have been dragging the radio down. So maybe the last guy he knew something I didn't know about how to pick capacitors worth changing, and maybe the last guy knew enough to leave that one alone down there, because so hard to do and most likely in good shape. I don't know. Okay, now my tail is between my legs a little bit. Not really. Well, I've tested all these bad capacitors this way and that, and the only one that has that characteristic is this Hunt's capacitor. So I'm going to guess what's happened inside this capacitor is the 2 electrodes. One of them has developed some kind of deposit or coating, some kind of corrosion product, something like that has happened to it. And so, hey, this may be now a diode to some degree, and it may also be a battery to some degree. So I often like to do this bizarre test. I think it's a little bit bizarre. Just reading the voltage that's on a capacitor that should have no voltage on it. I believe it's an indication of moisture inside the capacitor. So I have one here that I've had a short on for a little while now, because I was putting these under test. Even though you short these, you know, pop, that doesn't mean all the charge is out of them that fast. It takes time for all the charge to come out. So I'm gonna, this is on just DC volts. This would be we would expect 0 here. That's not 11 volts. I think that's 11 millivolts. Right. It's 11 millivolts. I'm not looking for a high voltage here. And it's really dropping, heading right for zero. I'll take one of these bad ones. Let's take this one. This one tested bad. In terms of leakage, let's see if it doesn't have a voltage. What? Come on. There we go. So now, when I first connect the lead, you'll see a number show up here, and then it'll drop. The first number I saw was about 250, maybe 260, something like that. Then the next number, the next time the meter calculated the voltage, it had fallen down to about half that. So watch again. Oh, I touched it. There we go. Let's try again. Wow, okay, that's obvious what happened there. Much higher. So I guess I just didn't make a really good contact before. So that was half a volt coming out of this capacitor. When I said, well, it's just retaining a charge. Who cares about that? Well, if it's just retaining a charge, and I disconnect this for a moment, and I come back on, it should say 142 and continue on down. But it risen up. So it's a really lousy battery. This is a really, really lousy battery. Or someone else explained to me where voltage comes from. So I think this has just got a little bit of galvanic action going on in it. It could even be between the foil in here and the metal on the surface of this lead coming in. That could be where this voltage is coming from, with a little bit of moisture. 180 something, so we're not seeing that gigantic shot there. Okay, enough of that one. Let's try another one. Notice I am picking the ones that tested with leaks. Oh, I banged it again. Here we go. Yeah, so that was over a volt sitting on it. That's hard to believe, isn't it? Let it come down. So again, if it's a really good capacitor with a residual charge, this would eventually drain. It'd take quite a while. It would drain it right down to zero. But if there's any EMF inside the capacitor at all, it won't get to zero. It'll stop somewhere. So another test that because I can't wait all day, I just take the lead off and see if the charge. Even this can be due to a quote regular capacitor charge. Even seeing this voltage come back, but 0.8, I don't think so. So I will leave these leads on, and we'll see what back. Oh my God, let's go back to this one. This is the one I really want to check out here. Come on, here we go. Okay, watching that meter. So I saw 0.121, I think it's dropping it right to zero. It's going pretty close to zero. Okay, I'm going to take off. Let's go on. 0.02, take it off. If you tried this with like a VTVM or something, I think they might, well, you might see all this still. Yeah, pointer momentum issues, are you trying to spot this kind of stuff? Here we go. So somewhere the 0.02 volts is returning in here over and over. So that's my theory on that. Moisture in a way. There's a couple more here that are worth checking. Like this one here is really worth checking. So you got to charge. So again, it's either a charge or an EMF coming out of there. So let it go down. It's going down, down, down. Okay, let it go. This is my own theory on what's going on. This isn't something that I've read up on. So in some cases, a charge like this in the capacitor, a little charge, it's not charged, don't use that word, a little EMF in the capacitor itself could be responsible for effects. I don't know. I don't know. I've never read about it, but I find it all the time. And I do not find it all the time too in new capacitors. There's certainly no such battery type voltage in it. So anyway, okay, that's the story on all those capacitors. Okay, so that basically ends the capacitor replacement process in this radio, at least to this point. All that's really left of old capacitors are, you know, a fair number of these mica type, which I think are highly reliable, and just these one, two, three here. All the rest have been changed everywhere. So what do you say we try this radio out now, give it a really good chance, and see what it really sounds like. I think I have not heard the short wave band work in this radio yet. Let's see what happens. Okay, I think we're ready to test this guy out. Got his antenna hooked up here. Just going to the antenna cable here that travels the length of my house. And it's switched on. So I have a very large, you know, as large as my property, loop of a wire outside for an antenna. Should work well. Got the audio connected, volume turned down. We're ready to go here. Boom. Any booms? Oh, the lights didn't come on. Whoop, hold it. Something happened there. Something didn't work out. What happened? This time, for once, I have it plugged in. Oh, what happened there? Why, uh-oh. Boy, I got a really super uncomfortable feeling now. Wow, that's a terribly uncomfortable feeling. So it could be the little shorting wire I put on the back of the switch just isn't doing the shorting thing anymore. Let's try that again. Maybe I overreacted. Okay, we're using a dim bulb, so nothing really terrible can happen here. 124. Okay, kill it here. So I've done something bad. Something bad has happened. It's as if the switch is off. Turn that switch off. Okay, I gotta tip this guy up and look underneath. What the heck happened? What did I do? Kind of scary when it's the main power where something weird is happening. So if I done something really stupid here, one of these wires would have lost its connection from me soldering. Wow, these just look perfectly fine. So we're not getting these lights to come on. That means these transformers are not being energized. I think it must be my junky shorting system here. It's hard to believe that didn't do the trick, especially when it did do the trick for a while. I mean, it's just about impossible to believe this isn't shorting this out. And I just want to make sure there's no strands sneaking under here and touching the well, I don't know. Take this up a little bit. Stick my finger on it. See, I've come to realize that even the things I know for sure are just things I think. I don't know anything. This is just crazy. I mean, there's a million contacts in here. Well, did that make some kind of difference? Let's just start it up like this briefly. Yes, it did. Yes, it did. Okay, that was just a little surprising. Well, something happened. I'm going to attribute it to the wires there. That's good. Safe and clear. Okay, let's try this again. Here we go. One more time. Hopefully one more time. Watching the dim lights. Good. Well, you can see these lights too. Excellent. Okay, we're back in business. Must have just been that temporary short I put on there. Oh, no audio. No audio. So I'll hook up the audio here. So again, you're not listening to this through a microphone, like a speaker microphone. You're listening to this direct wired, hot wired into the sound system. So even though what we hear may be hum-free, I don't think it is. Pop in the last two 45s, hook up that amplifier, and I think we're going to have some hum issues. Okay, so I can hear that rattly, I don't know what they call it, rattly sound. I think it's coming from here. I'm just trying to block the sound from the microphone and see if you can hear it. So that's something to look into. Okay, but for now, it's a question of what we can hear. And up the volumes on the control panel here. Sounds good. Ready now. No, volume. So I barely turned it. It's got lots of oomph. Now, what band? I think I'm on the AM band. 1, 2, 3, 4, 5, 6 slots. Oh, there's only 4 bands. Look, let's see the capacitor. Let's squeeze over there. You get an idea where I'm tuned. I'll put it over here. That's not so good either. Okay. Kind of a strange sound there. Got really quiet at the end of the band. Assuming again this is the AM band. Anybody up? What's going on? That's pretty interesting. So now you're just hearing this through the microphone up above here. You're hearing an audible sound coming out of here. Goes on right in there. Let's turn the volume up. Well, this will be a curious thing to investigate at some point. And I can tell you right now, another curious thing to investigate is the magic eye. I've already gone ahead and took a look at it, and there's lots of weirdness going on there. Let's try another band. I'm getting nowhere here. So we will go this horrible sounding switch, but I think it's just the mechanical stops in there. Ooh. Doesn't get much more quiet than that. Dead band. Oh boy. That's not what I was hoping for. Dead band. Tube number 1, tube number 2. Inject the signal in tube number 1, you can't hear it. Inject it in tube number 2, you hear it. There's something going on up in here. So I mentioned I don't think I ever heard the shortwave band work. Let's go another. Oh, that's the top. Where's the glass for this? So I think it's just a 4-bander. Let's go. Get it. This slot is supposed to line up with the light. That lines up. That lines up. Oh man, this is just a terrible feeling. Oh boy. Nothing at all. It's just like a miracle. It works in the AM band setting. Seems to. One more thing. Let's pump in a signal into the antenna and be sure about things here. Try to be a little more sure about things. If I can't pick up a radio signal, I'll just make my own. So it certainly is reacting to the antenna. No question about that. Oops. Let's put this here. Turn that down. I can hear it. So probably the signal generator is on the IF frequency right now. Nope. 14. 1401. 14. This is tuned in the middle, nowhere near 14. Oh, there's something very wrong here. Oh, I hate to say that, but really. Let's go to the other end. Should get it here. Somewhere. Oh boy. Okay, let's go in the middle. Maybe this isn't the broadcast band. In the middle. So that's going to be around a megahertz or so. Just mess around with this. Give it more power. Yeah. Okay, we're really blasting it now. I did not hook up the ground lead over here. So that may weaken the signal from the signal generator. There he is. Found him. Okay, so I have the capacitor. It's almost closed, and it's picking up a signal at 900. Wow. That's really unnerving here. See if there's any other place. I'll leave it. So the capacitor again, the big capacitor is almost closed, almost fully meshed. Okay, so this is up around 1890. It's right off the AM band. And for some reason the radio's reacting to it. Now, it could be images coming through. Wow, this ranks as... That looks like one sick puppy of a radio. Oh my gosh. Now, stupid things like this have happened to me where I've actually had this on the wrong band, and then I'm ramming in the signal at the wrong frequency, but it's managing to come through, and I get all turned around and twisted. It's really just me. So I need some certainty on the band setting here, but I think there is a lot of certainty, frankly. Oh, isn't that something? Hey, hey. Okay, that's the giveaway. And it's just getting stronger at the wrong spot in the band still. So, you know, a possibility here is the radio is so far out from those capacitors, old capacitors, that story's not going to hold up. I was going to say it was so far out that it got retuned to this situation to enable it to operate. Now I've put the proper capacitors in and it's back over where it's supposed to be, but it's tuned way over here. So you get all this funniness going on. Good story. I don't know how true that is. Wow. So maybe I did not do the front end alignment last time around. I just did the IF to make sure it was doing its thing. Maybe we do the front end alignment. This whole thing will clean up. It's probably worth doing that at this point. Wow, this is really not where I expected to be here. And the switch. We gotta do something about that switch, because when I go onto another band and it's dead. Oh, that's not dead. That's not dead. Antenna. I think I'm on a short wave. Oh. Okay, there's a lesson. There's a lesson right there. Third hole is the third hole is the AM. Okay. We can rejoice. Rejoice. Okay. That's good enough. That's good enough. That's all we needed to do. But let's keep going. Now, what's the story here? This is off alignment. Isn't it supposed to stop like that? That's the end of the run. So this light is supposed to be sitting in behind here, shooting light through the gap. Oh, that's right. The gap is lighting up different, these different little triangle marks on the front. So each time this hole should line up a little differently. Yeah, that's what's going on. Okay, great. So what's this? It's a whole lot of nothing still. Okay, so this is fine, except it's not working. Okay, so you can see that this is moving across. So it's counterintuitive. It's lighting the one most to the right when you have this turned. That's not so counterintuitive. Is it? I'm all confused here. So that's a short wave band. Okay, let's go 100 on this. It's not exactly the best time of day for short wave, and I don't know what frequency I'm on here. Picking up some stuff. So a couple of times I've been on this band thinking it was AM when in fact it was one of the short wave bands. Yeah, that was a little bit of a leak through from my signal generator. Back to the AM band. I'm pretty sure now is the AM band. Sounds really good. If you like funny Star Trek noises, sounds great.
statisticians and experts reviewed the coverage and Yale Insurance Services, and they said, yeah, well, this is not important anymore. Okay, we already got one.
Tone control.
Yeah, we don't need this. Yes, this has to stay. Yeah, we'll cover this. This is important. This is important. And they delivered 11 recommendations regarding tests and procedures to Health Minister Christine Elliott. We had her on the show at the time, went over some of the changes.
Okay, now I'm going to listen to this really carefully. Not what she's saying, but the sound of it.
Because we have this test, it's a redundancy, so we're getting rid of them, and I think that is something that is admirable.
Responsible.
Yeah, that's good. It's not a bad thing.
We're gonna.
Well, I think it's okay to this point. I think that's okay for now. So I think alignment is going to boost that up quite a bit. I'm on a wire antenna. It's a lousy antenna for this kind of stuff. If I put the loop antenna on here, I think we would get a really strong, clear signal at this point. So I think we're good. I think it's good. It's good. It's good to this point anyway. Great. Thanks a lot for watching. And what's next on this will be an investigation into the magic eye, and I already hinted. There's lots of interesting things about the magic eye in this radio. So thanks for watching, and enjoy your day. I will enjoy mine.